Hello, statistics friends. This is Gary Parker coming live, well, now recorded from my backyard in the summer of 2026. Welcome to week two. I'm sitting out here with my statistics book. I hope some of you had the chance to get the print book to get off the screen a bit. It helps my mental and physical health quite a bit. Let's take a look at what we're doing this week in our Canvas course. All right, get out of the way there. And you can get out of the way too. All right, so hopefully you got through all of the getting started stuff last week. You read the syllabus, you took the syllabus quiz, you read about how to write for a class like this. So when you submit things in writing to me, when you answer questions, you don't just write 25 goals for example, or the average is 32, you would state a sentence like the average age of a soccer player in the World Cup is 23 years old. Right. We want to be descriptive so that someone doesn't have to look back at the prompt or the question asked to say, figure out what the heck you're talking about. If you didn't read that, read it. Thanks for submitting some autobiographies. It's nice to get to know you all. And thanks for checking out the testing locations. And I know a couple of you have questions about that. I will get back to you. I probably have gotten back to you by the time you watch this, I hope. Week one stuff, again, a little more stuff to do in week one because we have some orientation to do. And then I wanted to kind of clear the air about what I expect in terms of AI. So you should definitely, well, I wouldn't say definitely, you should consider using AI for assistance, but you shouldn't have AI do the work for you. So it would be inappropriate for you to open up the practice problems, copy a question into AI, get an answer from AI, and just paste that answer in. Right? That's not an appropriate use. What is an appropriate use is if you're stuck on something to ask for help, that's okay. Or if you wrote up some response to have AI consider the prompt in your response and offer feedback on it. So use it as a tutor, use it as an assistant, but do not use it to do your work for you. The point of this class is not to collect points or to check off a box for your degree. It's to learn something that will be useful in your life, I hope. Um, let's see, what else do we got going on? Week two, there probably won't be a surprise quiz this week, but there is the regular reading quiz about the sections covered. It's important that each week you go to the homepage of the course and do things like check out, hey, what are the goals for this week? What am I supposed to do? This week, we're focusing on quantitative variables. Last week, we learned about what is statistics, how we do descriptive statistics, how we're going to branch into inferential statistics in a few weeks. We took a look at what is a qualitative or categorical variable, and I'll review a little bit of that today in this video, and then there's a bunch of other videos. And so usually the first page in the week is going to be the goal. Second page is a series of videos, usually from me. Sometimes I include some other ones. And then typically we get into the quiz and then the practice problems. Again, I'm probably not going to assign that surprise quiz this week because we have enough to do at the moment. All right, so just wanted to show you a few more things. There will be a written application for this week. I've got to pick a data set for that, and there's videos on how you're going to attack that particular problem. And I have a couple of extra pages about how to make charts and graphs for a quantitative variable using a spreadsheet and some new features Excel added last year for histograms and box plots. Excel box plots still suck. Google sucks more. I find Google Sheets easier to use than Excel. I don't care what spreadsheet you use as long as you can use a spreadsheet. And again, there'll be tutorial videos on how to use a spreadsheet. And most of the stuff we do is the same, except for charts. Spreadsheet companies that make spreadsheets can't seem to agree on how those should be designed and implemented. All right. I asked you to fill out a survey, the average person about you survey, where you entered some questions about age and gender and hair color and eye color and so on. So I just want to play around with that a little bit. A cool thing about using a Google form is then I can get a look at the responses, and it looks like Google is having a hard time loading that. Let's try to reload. Okay. And so Google, their program in the background will, if possible, try to make a chart based on that data. And if it can't, or it's not sure, then sometimes it won't. So the hair color is a rough one because people could type whatever the hell they wanted. And there's all kinds of misspellings and caps versus no caps and spaces and no spaces and couldn't parse that. But the eye color, it could because I gave it just specific eye colors to choose from. Height was weird because some people misentered information, which we'll look at in a minute. So it did not make a graph for that. Um, Again, sometimes it makes graphs, sometimes it can't. It depends on the range and type of data. Cool thing about that, though, is you can always get it in a spreadsheet. So if I select that button here from the form, then I have all the data in a spreadsheet, and then I can analyze the data. And so usually what I'll do is I'll make different tabs along the bottom here to play around with the data. And when we use a program like Google Forms or Microsoft Forms to collect information and then analyze it in a spreadsheet, we should always leave the original data unedited. Sometimes data needs to be scrubbed for different reasons. And so we'll take a look at that right here. And again, you don't want to, you always want to have an original copy of it in case you make some kind of error scrubbing the data, or just again to have that original copy. And sometimes I'll make a whole new sheet, but usually what I'll do is I'll just make new tabs in a specific sheet to play around. All right, so there's some new data in here since I last looked at it. So I'm just going to grab the age column here, selecting the B at the top of the column, and then I can copy that, and then I can create a new tab, and I can paste it in. And for example, some things I might do with this is check out, what's the minimum value in the data set? What's the maximum value in the data set? And I'm not going to scan that and do that. I'm going to use commands to do it. So if I type equals for a command and then I start typing min, I can see, oh, there's a function called min that finds the minimum value in a numeric data set. Cool. I want to do that. So I select it and I'm just going to click the A at the top to select the whole column. Sometimes it is appropriate to select the whole column. Sometimes you might just want to select the numbers from top to bottom, and Control Shift down arrow will scan, and those empty lines are stopping it. Went too far. So sometimes we might just select from the top first number to the last number. Other times we might just select the whole column. Depends on the function. In this case, it's safe to use the whole column. Blank cells are ignored and words are ignored with the min function. And again, you have to know what functions, how functions behave in order to decide something like that. So equals max. I want to do the max. I want to use every piece of every number in that column. Enter. So I can see the min is 2. Huh, how does somebody have an age of 2? That's kind of weird. Max is 58. Okay, so there's some problems with this data. So then it looks like I might need to scrub it. So next thing I might do is for that column, I'm going to go to, let's go data, sort range, advanced, tell it it has a header row, and I'm going to sort smallest to largest A to Z, and then I can see 2. Right, so 2, I've never had a student that was 2. So somebody mistyped that, and I can then just delete it. I don't want to do that in the original data set, but I can do it here. And again, that kind of thing happens. There's errors in entering, and then there's misinterpretations of what somebody ought to type. For example, somebody asked me a question about their average commute time, and they had said their average commute time would be 140 minutes per day. But the question was, what's the average daily commute time? So then you have to consider, well, some days you work and some days you don't work. So if you work 4 days a week and you commute those 4 days and then the other 3 days you don't, then that means you would have 4 140 values and 3 values of 0, right? So your average would be less than 140. And when collecting data, when people submit their own values, it can be questionable. And so if data really matters for some analysis, it should be collected by a professional that can, say, ask follow-up questions to clarify they're getting the right values for that data. So something to consider there. Data is simple in some sense and complicated in others. Let's look at another data set. Actually, no, let's go back here. One important thing about quantitative variables, so age is a variable. Each person you identify has a different age. It varies from person to person, so it's a variable. Gender is a variable because it varies from person to person. Age can have a lot of different values. Usually we give it a whole number, like I'm 56. But I have a friend who just turned 7, and my guess is in 6 months, he's going to say he's 7.5. Right? So it's not necessarily a whole number. Where was I going with that? I don't know. Anyway, oh, I know. In terms of analyzing a single quantitative variable, there's only really two appropriate graphs you can make with a single quantitative variable. It's a histogram or it is a box plot. And so I want to take a look at two of those right now, quick. So I'm going to highlight the data. In this case, most spreadsheets, you can highlight the whole column. Some spreadsheets, you can only highlight the numbers. It depends. Google and Excel, this usually works fine. And then I'm going to insert a chart, and the system will guess. So a line graph for a single quantitative variable is meaningless. So that is bullshit. So we're going to change it to something that's meaningful, which is histogram. If histogram isn't suggested, then you have to scroll through the list and find it. Histogram. And then what the computer will do is it will guess at values for the bottom. Generally for a histogram, and this is in the notes and the other videos, you want to have between 5 and 20 columns. This looks like a few too many. And you want to have nice numbers at the bottom. Here, my numbers are going from 15 to 16.8 to 18.6. So those are kind of lame. So we want to fix that. So I'm going to customize my histogram. And again, this is way easier to do than Google or than Excel, but I have videos on how to do it in Excel. Let's see, the data goes from 15 to 60. So I'm going to try jumping by 5. Yeah, that's nicer. Not too many columns, not too few columns. If I tried to jump by, say, 20, that sucks. There is no best histograms, but there are certainly bad ones. So that's a bad one. The first one I got was a bad one. That's a good one right there. Often we talk about age groups, like someone being in their teens or 20s or 30s. So I might want to break it down that way. So I could say, let's have a width for these columns of 10. But I don't want to start at 15. So I don't have anyone under 10. So now I need to tweak a little more. I'm going to go down to the horizontal axis, and I'm going to set a minimum value of 10. So now I have 10 to 20, 20 to 30, 30 to 40. That's nice. Other things to consider. This chart has no useful titles. Notice it says age on the left. These are not ages, 400, 300, and so on. These are counts on the side. So for example, there are around 300 people that have completed my survey that have an age between 20 and 30. Right? That's called a frequency. That's a summary statistic for a group of values in a quantitative variable. So often we're going to have to adjust the titles. So I'm going to say ages of BMCC math students, be a good title. And then for the vertical axis, technically it's frequency. But I usually think about people that would see this. Like if my mom looked at this graph, she's like, what do you mean frequency? Frequency of what? Oh, okay, let's be a little more specific. Number of people. That's a better title for that. And the bottom, that's pretty straightforward. That's just age. So horizontal. So anytime you make a graph like this, a histogram, you should have 3 titles or labels. A good title for the top. Sometimes a subtitle might be needed if it's complicated. And then you want to label, what do the numbers on the horizontal axis mean? What do the numbers on the vertical axis mean? Got to be clear. All right, another place we might go is I'm going to copy the data in a different way. I'm just going to copy from top to bottom. And then I'm going to go over to useful websites. And an app that we're going to use every week from now on is called StatKey. And StatKey is a piece of software that was developed by the authors of our textbook. Notice it says lock, 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 and lock. And then for the first few weeks, we're going to be analyzing this first column of stuff. And then in week 4, we'll jump into this column and then this column, and we'll analyze mostly these two columns for a little more than half of the term. Okay, at the moment, I have one quantitative variable. And again, there's lots of other videos that do this. StatKey comes with a whole bunch of predefined data sets that you can choose from, or you can edit the data, Control A to select all, delete, and paste in your data. Now, mine does not have a first column identifying whose number, whose age each of those are, so I'm going to uncheck that. But I did put the title at the top. Blanks aren't a big deal. So always pay attention to the checkboxes when you edit in data and StatKey. Okay. And then a cool thing is it quickly does basic summary statistics. So this week you're going to learn about mean, standard deviation, what Q1, quartile 1, and quartile 3 are, and what a median is. And then instead of doing a dot plot, so each dot is a different person's age, I could do a histogram. And again, there's no best histograms, but there are bad ones. This one is okay. If I point to a column over on the right here, it will say what's the lower and upper bound and how many are in that column. Right, so I can see the first column are ages from 16 to 20.2, and there's 280 people in that column. The numbers at the bottom don't match. So it goes 20, 25, 30, 35, 40, 45, 50, 55. So it looks like there are what? 1, 2, 3, 4, 5, 6, 7, 8 columns there. So I'm going to readjust this to go from 10 to 60. Is that what I want? Or no, maybe I'll go from 15 to 60 and put in, I think I want 9 columns. Eight columns. And I missed, okay. 9 columns. 15 to 60, 9 columns, and then I can get the numbers at the bottom to line up. So StatKey, I have to tweak if I want the column widths to line up. Excel gives you the option of entering the number of columns or the width of a column, or a bucket, we call them also, or sometimes they're called bins. I think Google calls them buckets. They're columns ultimately in the graph, and Excel calls them bins. So in Excel, you can control the bin width, or you can control the number of bins. In Google, you can only control the bucket or bin width. All right, so you're going to learn about histograms this week. Histograms describe the distribution of values. For example, here I can see most people have an age between 15 and 25. And there's only a few individuals that were over 50 that took a math class at BMCC with me, or actually a few other teachers use this form also. But it's not all math students. It's math students that do statistics. So that would be like Math 105, statistics, math for elementary school teachers, might be a couple other classes there. We would say this data is skewed to the right because there is a tail to the right there. So StatKey is a great app because it will quickly give you the basic summary statistics and a histogram and a very nice box plot. Box plot is about the 5-number summary. So that's the min, the quartile 1, median, quartile 3, and the max. So min is off to the left here. Then the beginning of the box is the first quartile. third quartile, or sorry, second quartile or median, third quartile, and the max is out here at the end. Any points that are plotted are considered outliers. So in this case, there's a group of people that are unusually older than the majority of students that take math classes at BMCC. And you'll learn about how to calculate what does it mean to be unusually large or unusually small. Every data set's different. If we go back to other stat key data, we'll see that sometimes there are no unusually large or small values. Other times there are, in this case, unusually large, and once in a while you'll see unusually small values out there. Anyway, there's lots of data. It's all different. Every box plot, every histogram is going to be a little different for each variable we play with. All right. Other things to consider. Whenever we look at a data set, it comes from a sample, and a sample is a part of a population. And so we're always curious, given a sample, what was the target population? So given the sample of data I have in this form here, what is the target population? Well, this particular form here was filled out by students in math classes that do some statistics at BMCC. So what's my target population? Do all students at BMCC take a class that has statistics? The answer is no. So I guess the target population here would be BMCC students that have taken some math course that involves some statistics. Did every student at BMCC who did statistics fill out this survey? Not necessarily. BMCC started in the early 60s. Does this count students back then? Probably not. So I might say students since 2020-ish at BMCC who have taken a math class that has done some statistics would be the target population. My sample would be, if I consider that column there, 631 students that filled out this survey, right? That's not all of the students that did some statistics in a class at BMCC in the last 6 years. So sample versus population are two different things. Let's look at another one. I have one here called nutrition study. And nutrition study, what is it? Well, I have to go look that up. So useful websites, data set descriptions. This came from the book. And I am going to search for nutrition study. And so then it's up to me to come here and review 315 observations. So the sample size here is 350. They seem to be people. And then I have to read the details down here. And sometimes I have to go look up the source to get further information about it if I'm not clear. So this data is from a cross-sectional study to investigate the relationship between personal characteristics and dietary factors and plasma concentrations of retinol, beta-carotene, and other carotenoids. Study subjects were patients who had an elective surgical procedure during a 3-year period. Right? So that describes the sample. Question: what broader population was this selected from? Well, given that it was in the American Journal Epidemiology, and it was based on people who had some kind of surgery with a biopsy, I'm assuming it's adults in America. The study was done in 1989, so American adults in the late 80s might be the target population. Yeah, that sounds pretty good. You might restrict it more and say, no, it was only American adults who had some kind of surgery to check out some kind of, to biopsy something. Maybe. But again, I think they're looking at relationships between personal characteristics and health. In this case, people had health problems. So they're not necessarily looking just for people that have health problems. I think they're trying to find out if there was something about these people's personal characteristics or diet that led them to have these health problems to better help all American adults. Right. So I got to think about that for a bit. So I'm going to go with the target population here is all US adults in the 80s. Have things changed much since the 80s? Nah, we still eat the same shit we used to eat. Yeah. So maybe it's all adults since the 80s in the United States is my target population. Okay, again, we have to reach. Sometimes when we look at the original study, they'll state what the target population is, but we don't always have that information. So we have to always make a guess. What is the target population? And you have to differentiate between the sample, the individuals you got data from, and what is the broader group they were selected from. Big idea. We're going to review that every single week because sometimes it's tough to figure it out. All right, those are the main things I wanted to go over with you today. It took a little longer than I thought, but statistics is fun and interesting, and every data set is a little bit different. So enjoy reading the book this week. If you have questions on stuff, get back to me either through Canvas. If you have questions in the practice problems, use that message instructor button, and I'll get back to you. That's it. Stay in touch. Do good math. I'll see you in the near future.